In this video, I want to show you how to generate the statistics printout for working with binomials. And so let's assume we're working a problem, and let's assume we have an n of 5, maybe a probability success of zero point 0.5, and we want to know the probability of at least 3 successes, or something like that. Any kind of binomial. You've met the conditions, and now you want to go and figure out some probabilities. Well, we've talked about how you can use a formula that's not very user-friendly. There's some tables that you can find probably in the back of a textbook somewhere. But if we want to use a software, we're going to come here to the Statistics menu, and we're going to go down to where it says Probability Functions. And when I click on this menu, you can see that there are a lot of different probability distributions that we can work with. For most part, in an introductory stat class, we cover the binomial, we cover the z distribution, and then usually the t distribution gets talked about, maybe the Poisson. But I'm going to limit this discussion to the binomial. And you can see when I click on the binomial, it gives me different values of x, n, and p for me to enter some values for. And n and the p have been identified as part of our conditions or criteria for understanding that we're working with a binomial. If we have an n of 5 and a p of 0.5, those are the values that I would plug in there. If I want to figure out the probability of more than 3 or at least 3 successes, I'm going to use the value 3 as our choice for x, and I'm going to hit go. And it gives me the probabilities attached to the value or surrounding the value 3. And this version of statistics, a lot of software only give this first probability, the less than or equal to, what's sometimes referred to as a cumulative probability. If you look at some tables and you look up the value of 3 in the cumulative tables, you'll see the 0.8125, or maybe it's rounded to 0.813. This one also gives the probability x is greater than 3. And you can see it uses the value y here, which is interesting. I'm not sure why it does that. If you want to figure out the probability of equal to 3, it'll give you that as well. And so knowing that you have a binomial, you just plug in the values of n and p, figure out the value of x that you want to work with, and go from there. So that's how you generate probability. So let me give you another example. Suppose I'm flipping 20 coins. Probability of getting a head is 0.5. What's the probability you get at least 6 heads? At least would be a greater than or equal to probability. I can hit go. Okay, the greater than probability is 0.94. The equal to probability is 0.03696. You'd add those two numbers together. If you wanted the probability of at least 6, you take the greater than and equal to and add them together. And so that's how you work with binomial probabilities.